Hi, welcome to day 25 of 100 Days of Code in IoT Challenge. Today's project is going to be a little bit more challenging because what I would like to do is to upload a file that is stored on ESP8266 in the flash memory, and I would like to upload it to the cloud, to AWS S3. And on top of that, I would like the whole process to be secure. So I'm going to do it over HTTPS and stream the file as a binary. So as you can see, the difficulty level today is going to be a little bit higher. I'm going to start from giving you an overview on the solution I'm going to be building today. So the goal is to make ESP8266 uploading a file to the cloud, from the flash memory to the cloud, right? So on this diagram, really, our first step is gonna be uploading the file from the computer to ESP8266. I've got an image file prepared for the demonstration, so that's what we're gonna do. I've already done this a couple times in the previous videos. It is pretty straightforward with Visual Studio Code and PlatformIO command. Okay, so that's one thing, to store a file in the device flash memory. Then I'm gonna make use of Presigned URLs with AWS. The way Presigned URL works is it's a feature that allows you to generate a very specific secure URL with expiration time. And then you can use that URL to make a request with the binary data to upload a file in a specific location on S3, right, on the AWS file storage. However, the problem with the Presigned URL is that you cannot really do it from AWS console. You cannot really do it from here. This is the bucket I'm gonna be uploading file to. And it is not possible to do it from CLI as far as I know either. So the only way really is to do it programmatically. And for that, the thing you might be already familiar because I've done it in my previous videos. I'm going to use the serverless framework and deploy AWS Lambda behind API gateway with the get endpoint that is going to generate that presigned URL and just return it as a text. So ESP8266 really is gonna make two requests. First is gonna be to AWS Lambda to get the presigned URL, and then it's gonna use the presigned URL to send the file, to stream the file to S3 straight away, right? I think you're gonna understand it better from the practical point of view when I be just doing all of it, right? Okay, so let's move to the code. We're gonna start from this part. So serverless framework really, and yeah, let me just open a terminal, and I'm just gonna go to my PlatformIO projects, to the projects. Okay, and I'm gonna use a command, serverless command, to create a Go Lambda function. The path is gonna be presigned, maybe upload, maybe presigned URL. And yeah, this is essentially gonna create the folder and the project inside with the Golang Lambda function. And let me just open it. Okay, so that's just a template project. Let me show you. There are two functions, hello and world, and that's how it looks like. Functions hello and world, two endpoints. We don't need two endpoints, we just need one endpoint. And what we need first is to give it a name. So let's just call it Presigned URL, maybe something like that, get presigned URL. Then this is gonna be, yeah, let's just call it get presigned URL. And for the path, just presigned URL, I think, instead of upload. I actually put upload here, but this is not really doing any upload. It's just returning the presigned URL. So method get. And what also we need is the IAM statements. The one we really need is this one, is the put object. So let me just uncomment that. And here I am supposed to provide a bucket name. So I have prepared the bucket on S3. I call it 100 days of code upload. It is empty, as you can see, no files, no objects. And let me just paste the name the simplest way. So we've just given a permission to put object, this is required for presigned URL for upload, to our Lambda function, which is this one, get presigned URL. And since I changed the handler name, I need to go to the makefile now and reflect that here. So get presigned URL is gonna be the name of this folder, and world is not required anymore. So that's what we've got. From the serverless file, this is gonna be it. And on the makefile, this is it. Now the main.go. So main.go, this is just an example handler. It just responds with the JSON message. Most of this stuff I'm not gonna need. So we just need this bit on the response. I would like my response to be pointer though. And also instead of context, I would like to take a request. So let's create another type. Events API gateway proxy request. That's what I need. And that's what I'm gonna take here. So request R. I'm gonna explain why I need this request in a second, but before I do that, let me create the init function and a variable to I'm gonna call svc, and the type of this variable is really gonna be s3, but also pointer to it. Inside the init, I need session. So that's gonna be something like session new session, and then svc is gonna be s3 new, and that requires me to pass a session. So that initialize s3 service. I am going to need this to generate the presigned URL itself. And how this is done? First, I need a request, and the request is going to be svc put. Okay, that is not really telling me anything. What I need to do, I think, is run a make build. So this is going to install all the dependencies required. And I'm going to reload it. Okay, and also let's make it more visible for everyone to see. Cool. So again, I'm gonna try again. So now I'm just gonna do request, and I'm gonna ignore error, and svc dot, yes, there it is, And that method is called putObjectRequest. PutObjectRequest, and this requires S3 putObjectInput. And here I need to pass key. And that key is essentially the name of the file that is going to be created once the file is uploaded, once the binary is sent to that presigned URL. Okay, so that's gonna be the name of the file appearing here once it's uploaded. So let me maybe, this is the moment I'm gonna use R as a request, because I'm thinking about getting query string parameters. Key. Again, going back to this overview from here, you see this is my idea to do like key equals and the file name and extension. So that's how I'm gonna extract that key from the request. And we also need a bucket, and the bucket is essentially the same as this name. So I'm not really gonna put it behind environment variables right now. Don't wanna do any additional work here, except for what is really required to finish this Lambda function as soon as possible. Yeah, and here what we need is, this is what we're gonna get, so maybe I just call it URL or presigned URL, presigned URL and error, and that equals s3 dot, sorry, that is not s3, I think this is, request presign, and inside the presign we are supposed to provide the expiration time. I'm gonna make this presigned URL expire after 15 minutes. So the ESP8266 HTTPS client will have 15 minutes to upload it. Maybe I decrease it later on, but for now, I guess this is fine. Okay, so if error is different than nil, I'm just gonna return nil and error. So that will be 500. And now I'm gonna use presigned URL. So that's essentially a string, and respond with that. No headers, really, don't need any headers. That's gonna be just plain text. So I think this is it for our Lambda. Let's give it a test. So make build first. Let's see if it builds. Yes, it did. And now make deploy. I've just reminded myself about one option that is missing here. And this is the region. I need to change that region to EU West 1, because that's the region I've created a bucket in. So yes. And now make deploy. Okay, done. That's the URL to our Lambda, to API gateway, essentially. Let me test that. So it is that one, but the path is /presigned URL. So that's what I need to include. And also the key. So the key, let's just do test.txt for now. And this is what we got, right? So that's text. A presigned URL is a bit long, but this is because of all the security. And what we are supposed to do is to use this one with ESP8266 HTTPS client to deploy something there, right? We just need to include the stream of the file that we would like to deploy. But yeah, that I'm gonna show you in a second. Yeah, for the Lambda part, Lambda function part, this is it. As you can see, this is working. Please let me know in the comments if you like to see more videos about serverless framework, AWS in general, because so far I haven't done much, but if there is interest, I can do more. But yeah, anyway, That's done. I can close IDE on that example. And now let me just go back to the diagram again. We're gonna focus on ESP8266, the communication, and uploading the file. I actually start from uploading the file. Okay, so for that we need a new project. The project with PlatformIO. So PlatformIO quick access is what I need. Then open, new project, and let's call it file, or maybe HTTPS file upload, node MCU, and that's it. Let's create it. Cool. 1 second, we should see platformio.ini. Yes, there we go. And here, as you probably remember already, monitor speed. That's for the serial communication. And then board build file system. That's little fs. And there is another one. There is another one on the flash size. And I'm gonna use a different one because I would like to have a little bit more memory. So 3 megabytes for the spiffs, for little fs really. So that's the initial configuration. In the main CPP, I need to initialize that serial communication here with the same monitor speed, the same baud rate, and the delay again for IDE to not have situation where it started when device starts to send the communication, but we don't really see any messages yet. So a small delay at the beginning. Okay. Another thing is the library. The core library that I've built during one of the refactoring sessions. A link to this git clone command in the description. Don't forget to check out today 24. Sorry, I did it again. First change directory to core and then check out today 24. This is yesterday's code, yesterday's changes. Maybe what I do is to show you quickly and remind what I've done. So I introduced HTTPS client with the certificate store. This allows us to make a request to any secure location, any secure URL on the internet, without having to download a PEM certificate beforehand, right? So that's using Mozilla certificate store. And yeah, actually today we're gonna have to use the Docker command, the Docker container, to download this certificate store as well. But yeah, this is pretty straightforward. I'm gonna show you in a second. Right, this is mainly the class we're gonna be working with today. For those who watched yesterday's video, for those who haven't, I recommend watching it. For those who watched though, what we're gonna focus today is this part. On the requests struct, I'm gonna turn this body into a stream, because to send a file, we need a stream, otherwise we run out of memory, right? So we need to send it like just chunk by chunk, little by little, to AWS S3. Cool. So yeah, let me go back to diagram. This bit now, file system upload. The file system upload. To upload files from your computer to ESP8266, we need the data folder. And then we need to put something in the data folder. So today I prepared, let me show you. I've got this one. And let me check the... Okay, that's 213 kilobytes on the disk. It was actually important to be bigger than the RAM memory on the device. So we've got it here. I'm just going to move it to the data directory so we can upload it to the device. Okay, there we go. And then what else I need is the certificate store. For the certificate store, I'm gonna change directory to data, and there is a simple Docker command that needs to be run, which is this one. It's my container I created to be able to download this certificate store quickly with the Python script inside the container. Again, I've put this command in the description of the video so you can run it yourself. If you haven't got Docker installed on your machine, I have put another link to official documentation so you can install it yourself, because you're gonna need that certificate store to make HTTPS request. And also, like, if you quickly look around YouTube, there's lots of videos about that. If you want me to do that, let me know in the comments and I can do a video how to install Docker. Okay, so I've got the certs.ar also downloaded. So that's what we need to upload to ESP8266. And we're gonna go to quick access now. Node MCU v2 platform and upload file system. Okay, so our files from the data folder are in the device's flash memory now. If you have any issues with uploading, first step is to make sure if the device is connected to the computer. Great. So yeah, data's done, and now I'm going to go to main.cpp, and here I'm gonna paste some code from yesterday. So let me start from all the required includes, and then the initialization of all the classes, and I'm quickly gonna go through them to explain why we need them, right? So HTTPS Client, we're gonna start here because this is the main class that we're gonna use today. HTTP Client, self-explanatory, right? It's going to make our upload request today. It uses cert store. I've done this yesterday. So I've made a copy from the single host HTTPS client, but changed the way this works with the certificate store. This is the reason why I've just deployed those certs.ar. Apart from that, we have Wi-Fi manager that we created here, and timer, and also SSID and password. And again, the reason here is because my library is trying to make everything like a self-contained. So HTTPS client takes all the required dependencies to connect to Wi-Fi, to synchronize time for the SSL verification, and it does it under the hood, so you don't need to do it yourself. And also the way this works is a callback based. So you usually pass a function, a callback function, C++ Lambda function to some method, and that function is evaluated once all the other operations are done, right? Okay, and one more piece of code that I'm going to paste in before we move to HTTPS client is this, which is again something I have done yesterday. This is to initialize the certificate store, the certs.ar file downloaded from Mozilla is the same certificate list that Mozilla Firefox browser uses. Cool. Right. So that does its job. Okay. So we are focused on this file. Let me copy its name, and I'm going to create here a const char pointer, file name, and this is gonna be that name. So that's gonna be something that we're gonna do. Let me quickly move to the diagram. So in our diagram, our ESP8266 needs to make a GET request first to get Presigned URL from the Lambda, right? So that's what I'm gonna do just now. So HTTPS Client dot send request, and then we're gonna do request build. We are supposed to pass a method which is going to be get. And to be honest, I was thinking about this interface of the build static method here. I've made the method, the HTTP method required, because like any request requires HTTP method. And I was thinking also any request requires URL. So I need to refactor this to force developer to pass URL as well, because at the moment, the way this works is you need to pass a base URL and then path and then headers and body. In our case, we're not really gonna pass anything apart from the base URL really, which I'm gonna turn into URL in a second before we actually compile our code and deploy. But hang on, before I do that, I'm going to pass this callback function here that takes the response, and as I've just said that this is the way the classes from the library, from the core library work. So usually you pass the callback, and that callback is gonna be evaluated once everything is done or there was an error at some point. And that's what happens with REST as well. Let me handle the error straight away. So if error is different than null pointer, that means something went wrong. And what we want to do is to just print this error out. Of course, you can handle it however you like. And here there is the success. For now, I'm just gonna print this. I'm just going to print rs.body, which is a stream, a pointer to stream. So I need to call read string, and I think a string is gonna be printed out. Right, and now to the base URL. So for the base URL, I was thinking what we could do with our request builder here. That takes method, I would like that to take URL as well. Not base URL, but the full URL. Because I'm thinking URL in the future, in the next refactoring session, should be a separate structure with separate methods, separate like components, members, and so on, right? Because this is not, I mean, URL is for me more like a self-contained structure that is separate from the request. It is a part of the request, but on its own, it's separate. But yeah, what I'm gonna do just now is to, you know what, we can actually call it method, because we don't have a method in this class. And here, I'm going to introduce, maybe just rename. So path is not required anymore. So on the request, where is the request? So on the request, we don't need path anymore, and that's gonna become URL. So in the request builder, that URL, the request URL, is gonna be assigned to the URL coming from here. One more thing that I have to do is to paste that in here and pass URL to request builder constructor. So yeah, so there is one modification. And now simply after the colon, I'm gonna pass the URL that we've already hit. It is this one, isn't it? Of course, we would like to call that file the same name as we have for the file name here. So what I could do is to quickly check what is the length of that URL. Or maybe, you know what I do? I've got a better idea. So let's do the printf in here. So we will have something like, yeah, again here. So I'm gonna create char, for now just 10, char array called URL, and here I'm gonna use printf, and this is gonna be the URL we use. One second, like that, and that is where we're gonna pass the file name. And now what we could do is to check, so 76 plus like 19, so let's do 128 length. And this is where we create the URL. Here I'm just gonna pass the URL, and that should make the request to the Lambda. Yeah. One more thing, timer.tick, otherwise we won't see anything. This is the core functionality of all the utility classes here, except for the event dispatcher. So this needs to be called. Next refactoring session, I'm gonna get rid of it because there is a way on ESP8266 to completely skip the loop but still attach a function to the loop. But not today. Okay, let me try to compile this. Right, some issues. I'm gonna go back. Okay, I think I know what those issues are. So one issue is here. That needs to be URL. Another issue is probably, yeah, that's fine. I've just fixed it. And another issue is here. We don't need to do it anymore. I can just do request.url now. So that simplifies it on HTTPS client as well. This sort of approach really follows the single responsibility, right? Because, I mean, more or less, because for me URL should be self-contained, object, separate. Right, okay, that compiled, and now we're going to deploy. And we should see the presigned URL on the screen. Okay, that's deployed. Let me connect to the serial monitor. Right, so the certificate is read. Waiting for NTP timesync. get code 200, and we should see something in a few seconds. Okay, so as you can see, this is quite a lot of data. That worked well. Right, and the next step, we're gonna use this response that we're reading here to make another request. Right, let me do it right now. But first of all, I'm gonna have to create another variable that I'm gonna put on the stack. And this is gonna be, let's call it presigned or upload URL maybe. Upload URL. And we need around 1600 length of this char array. And what we could do in here, so I'm still gonna print this out, I guess. However, I'm gonna print out the contents of this char array I've just created from the response on the body, because this is a stream. Once I read the string, I'm going to copy it to the char array, which is the upload URL. That's gonna be the char array that we want to copy it to. The size of it is gonna be size of -1. And here I can just, instead of, doing res body read string and see string, I can just do upload URL. So we will see something like that. And then in another step, I'm thinking about calling another function. So let's create another function. And this function is really gonna do the upload. So let's call it maybe upload file. And inside this function, again, send request. And then the response, there is gonna be response, res, and so on. And so on. Instead of URL, we're going to have upload URL. And the required method is put. I can do a simple copy paste for now on this bit. And again, response body. This could actually be serial.printf and the response code, I guess, because really S3 doesn't respond with anything except for the status code. Once we upload the file. So that makes our send request for the upload file. I'm going to run it here. So right after we print out the response body, the presigned URL actually. Okay. But yeah, we still have something missing, which is the body. And this is the moment I'm gonna have to modify HTTPS client, right? Because in the body, we only accept const char pointer. What we need to pass is a file, isn't it? So this is this file. So as you remember from my previous video, to open the file, you just need to call littlefs and open, pass the file name, The file name should be really a path, but because we are this is in the root directory of data, we can just pass this one without the slash at the beginning and pass the flag. That means we're gonna be reading from the file, right? So we've got the file, but there is not really any way to pass that file to the body because body only accepts const char. File is too big to assign it to a single variable. So we're gonna have to modify our HTTPS client, our request, essentially to be able to take streams. And that's something we're gonna do just now, right? So this const char for the body, I'm still gonna keep it, but I will rename it to body string. So our request will have like two different states on the body. There's gonna be one state when the body is string. So that's the actual, the way this actually works. And another way is gonna be with the stream. So I'm gonna define stream pointer body. And what else we need is the body size. Let me show you why. So this is the moment where we send our request. And at the moment we use the overload that takes a string. However, if you want to send the request where you pass the method and stream, let me show you, that requires a size as well. And the size, in our case with the file, is gonna be the size of the file. But because I accept a general stream here, it doesn't have to be a file stream. It might be something else, a different type of stream, some other class that inherits from stream. And for these cases, we're gonna have to force the user to pass the size as well. So I'm going to define it here, and I'm gonna call this a body size. Okay. Another thing I would like to do is to change this to class, so I can assign the null pointers in here. So we'll have body size as default is 0, body itself is a null pointer, and body string is also a null pointer. And let me just explain what I mean by different states on the body. So at the moment, on the request builder, we have a body method, and that method takes const char. I'm going to overload it and give the possibility to pass a stream here instead. So stream s, and we also need something like size t size. And in case someone passes stream, we're gonna set the body to stream, and then set the body size to size. Again, return this. We want this request builder to stay like Fluent API. Okay, on the body, I'm gonna have to modify it because now we have a body string that takes const char. Another thing is, if this happens, I would really like, and there was body already set, I would like to change it back to the null pointer. And another thing I'm gonna do here for the body string. So we'll never have both of them being set to not a null pointer, right? The actual a pointer that points to something. And the reason is that state I was talking about, right? So I would like the request to be either a stream type, or a body type. Okay, I can do another overload here. That is gonna be on the file. So I can take pointer to the file, and with the pointer to the file, I can just return body on the stream. So I will just pass through file, and as a size I can do something like size on the file, because file size method exists on the file but it doesn't exist on the stream, right? So this method is really gonna call that method with the size. So we just take advantage of the overloading of the method of the overloading here to simplify the code. Cool. So that makes the request complete, and now we need to handle that, because at that point we still pass string to send request. We want to pass stream or string depending on the case, and that case can be easily checked with if conditionals, right? So I'm gonna keep int HTTP code, and then I'm gonna do like if request dot body is null pointer, and because think about that, there's gonna be 3 cases here. One case is both of them are null pointers. That means we don't send any body, like for a get method, for example, right? And the next case is essentially body not being null pointer, but body string being null pointer, and another case the other way around, right? So it's gonna either be, the body is either gonna be stream or not stream, string, or empty, completely empty, right? So 3 cases we're gonna have to cover. So I'm gonna cover now the case where both of them are null pointers, and then what I'm gonna do is just assign to HTTP code HTTP send request, and there are 3 overloads here as well. One is the stream, second one is string, and there is this one, which is the one I'm gonna use right now. That is for this is the one I'm gonna use for the empty one. For the empty, I need to cast this null pointer to uint8 a pointer, and that's gonna be 0, right? So that's the empty body. Another case is when the body is not a null pointer, right? If it's not a null pointer, this is where I'm going to just again HTTP code. Maybe I extract this to a private method later on. This entire block of code, but not now. So method and then request body, and request body size is also required as for the stream size. And the third option is the one with the string, where we're going to just pass the body string. We don't need to pass the size. But you know what? Just to be consistent, I would like still the body size to be length. I think it's strlen, yeah, strlen b. So just to be consistent, it's not gonna really be used, but you know, the memory is gonna be allocated anyway, so why not make it consistent? Okay, so 3 cases handled here. I'm gonna compile that. Okay, so now it's just main CPP that complains because we haven't passed anything to the body, but now we will be able to. However, again, before I do that, something to consider here is the fact that for the request, we take a stream pointer, right? And if I keep the file like this here, the whole code is gonna fail. I mean, you know, I'm gonna, if I do something like that, right? I pass file here, this code is gonna fail because it's non-blocking. And let me just show you. It's non-blocking. This callback is going to be evaluated eventually. But before this happens, this function is going to go out of scope. And with going out of scope, this file variable is also going to go out of scope. And because of that, that pointer is not going to point to anything when this code is evaluated, right? And to prevent this kind of situation, there are two options we can go for. One option is to put the file somewhere, allocate some space on the stack for the file, or we could use a smart pointer, and that's something I'm gonna do. So here, I'm just gonna go for the shared pointer for the file, and that shared pointer is going to be passed here to this callback. And that's another thing we would like to do as well, which is closing the file, right? We want to close the file once the reading is done, because really, let me show you in a second. I'm just gonna pass the right pointer here. If we click through to the send request stream, to this one, it's not gonna close it for us. It's not gonna close. It's not gonna close the file for us, because I think the stream doesn't have a close method. That's why. So this is just reading from the stream, right? So just read bytes and write to the client, but it's not really closing our file. So that's why I had to do it here. Okay, let me try to compile. Try to do it here, right? And now I'm quickly gonna go through the code and explain how everything works. So again, here we just initialize everything. Then in the setup function, this is just a serial monitor. We begin initialize the file system and initialize a certificate store that is read really using a file system that is used for the SSL certificates verification. Then we prepare our URL to get the presigned URL for upload, right? So that's essentially just copies that and swap the %s with the file name. So that's gonna be our URL. Then we make a request to AWS Lambda, to API Gateway, right? Using this URL. That's just a GET request. And that request, if it's not successful, this is it for our program. Otherwise, we copy the response body, which is at the moment just a text, but a URL. We copy it to upload URL to the variable that we allocated here, a char array. We copy entire content to it. We print out the response body, the actual upload URL, and then we call upload function, upload file function. In the upload file function, we open the file for read, the file that is in the flash memory of the device. It is this image. I have uploaded with PlatformIO. And we create a shared pointer out of it. The reason we use the shared pointer is because that callback function is gonna happen eventually when this is long gone, right? It's gonna be out of scope by then, and we need to retain the file until then, right? Until the moment when this function is called. And that's what happens here, right? Because I copy this shared pointer to this callback, to this C++ Lambda, and I close the file here. So as long as this is waiting to be evaluated, this is gonna stay in the memory. Right, once this is finished, it's gonna be removed from the heap. And again here, just a quick check, like closing the file and just a quick check if there was an error. If there was an error, we just print out the error. Otherwise, we just print out the response code, because really response code is the only thing that AWS returns once you use your presigned upload URL. Okay, and that's it for the explanation. And now I'm going to deploy and we see if it works. So let's deploy. We should get all the information here. I've got my bucket prepared. It's empty at the moment, but the file should appear here once this is done. So let's see. Okay, so that's deployed. Let me connect to the serial monitor. And there we go. Okay, so it started. Waiting for the NTP timesync. And there we go. So what happened here? Right, we've got the GET request. We received the response body, which was the presigned URL for upload, and then it made a request with the put method to upload the file. And what happened here? We got 200. So let's see if we have the file. If there is a file in my bucket, is there? There it is. It is here. Let's see if this file has been uploaded correctly. So I'm going to download it. Okay, I'm gonna open it. It's the same file. So as you can see, uploading file is as simple as that. With the nice library I have created. So yeah, what we've got in this file, import debug. Okay, anyway. Yeah, so that works. I was even thinking it might not work straight away because there is one thing I missed. I thought I missed, but apparently this is not required. If you look, if we look again at our put request, I was thinking the content type is required and it needs to be set to octet stream, application octet stream, but it seems like it is fine. As long as we send the binary data, AWS accepts it, right? So just following this solution, we can easily upload the file to an internet location, right? It might be different on different websites. There's also a way of uploading the files with the for multi-part data, and this case doesn't really cover it. This is just for the binary upload to AWS S3. This is a good example, right? It doesn't have to be S3 though. However, this is just binary. For the multi-part, it is a bit more tricky because it's not built in ESP8266, and you have to make entire HTTP request manually. So HTTPS client cannot be, HTTP client really used with bare SSL cannot really be used for that. You have to prepare entire request, right? So you need to send the request as a string, prepare it from scratch. So very low level work needs to be done for that. But yeah, anyway, let me know in the comments if you want me to have a look at this multi-part. It may take some time until I figure this out, but yeah, let me know. I have seen there's not really many examples on the internet. not really any videos about multi-part. So yeah, again, let me know. I could try to do it for ESP8266, ESP32, so you won't have to do it. Right, for today, this is really it. There's gonna be a link in the description of this video to the repository with this code example. So if you want to use it, it is all free on the internet on my GitHub. Okay, and my plan for tomorrow, I think what's left for this file system videos is parsing JSON, right? It's parsing JSON and creating JSON. In general, working with Arduino JSON library. So that should be quick video. And then we will have this file system more or less finished. Not completely finished, there might be more videos on that subject in the future, but still, after that, we're gonna move to something else. I'm gonna go back to hardware and make some interesting, useful project. And this is it for today. If you find my content useful and you would like to stay up to date with my channel, I suggest hitting the subscribe button. Cheers and see you tomorrow!